we're going to go over some basics of what's called object-oriented programming. Essentially, this is a way to write software that relates directly to how the real world is organized. And it relates to using what are called objects. What's an object? It's a thing. Well, that's really clear, isn't it? It really is anything. An object could be a car. It could be a user. It could be a client. It could be an email sending module, where a module is one part of a greater overall thing. These are all things. They're all objects. These ones you can kind of relate to the real world. You can walk up and you can look at a car, right? You can see a user of a program. You can, think of a client of a business. This one, maybe I could spell email correctly. Maybe this one, maybe a little more abstract. An email sending module will be that part of a program that's responsible for taking a completed email message and sending it out on a network towards its destination. But they're all things. They're all objects. Okay, good. So, what is object-oriented programming? It's all about code reuse. Your software code needs to be reused. Rather than writing the same thing over and over again whenever you need it, make it so that you actually write it once and can use it in multiple places. That's part of the principle behind object-oriented programming. So, here's how object-oriented programming works. In your code, you're going to define what's called a class. A class is a category of or type of thing. So, where we had our examples before, you could have a car class or a user class, or to drop down to that bottom of the example, an email sender class. Now, here's what a class is. It's a definition of potential property and behavior. Let's make this real world. Let's say we have a car class. What's the potential property characteristics of a car? Well, there would be the color. There would be what body style it is, two-door, four-door, hatchback. There would be what type of engine it has. There would be whether it's a gas or electric car. Those are all properties. And this behavior, a car could accelerate, decelerate, turn right or left, go backwards. These are all property and behaviors of a car. And what a class is describing what it could be if you had one. The class is not something you already have. If you were going to describe the concept of a car to somebody, you'd be talking about the fact that it was a vehicle that could be used to transport people or things, and it would have some mode of energy transmission, i.e. an engine. It would have some way of having wheels that would let it move forward, or some device that would let it move forward across the ground. Right? Could be wheels, could be tracks. There's lots of different things that are a vehicle. But what you're discussing is, as a concept, what's the concept of a car? Not, I have a car, it's a Corvette. No, you have, as a class, a thing called a car. It's a description of a potential that could be. Well, fine. When you make one, when you cause a car to come into existence, that's called an instance of a car. It is also called the object itself. You have a car object. Here, where it was a car class, it's just a description of the potential behavior. If you ever had a car, I'm not saying you do, but if you had a car, here's some of the things it would look like, and here's some of the things it could do. Well, now we actually have one. We have Eric's Corvette, because a guy can dream, right? This is an object. What object is it? It's an object that has a certain type. And it's a type car. It's a car object. You could have a user object, to use my example from over here. You could have an email sender object. But in every case, what this is you're saying, here's a description of potential behavior for a thing called a car, or a user, or an email sender. I want to actually have one. My program needs one right now. I'm going to make one. And that is the instance of that class. You're going to have multiple instances, and that's actually what you're planning on because of code reuse. If you're talking about users, you want to have thousands of users potentially on a website or a business application used in a company. You want every single one to have a description of its generic behavior and properties, but then when you make one, when you hire a new user or bring on a new person, you want to actually have them inside the program, inside your computer program, and you want to be able to say at the time you create them, well, here's the name of that person and the social security number and their date of birth and all that sort of thing, and here is how I can assign what job they have. All of those things are the actual instance of having a user. They're not the theoretical description of a user if you ever had one. That's the difference between a class and an object. An object is when you actually make an example one of the thing that the class describes. You actually ask for one to be created. Okay, good. So let's delve into this a little bit more. How does this work? You're going through your program. And you're going through it in order, boom, 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 there's all these steps, and you get to one where it says, I want a new user. And this user is going to have a name, Erik G, and it's going to have a social security number, 555, and some other numbers. And it's going to have a date of birth, 5/24, and the year that was a long time ago for most of you. This is when you create the object. These are the properties you'd like it to have. So how does this work? Your program has been executing, and it gets to this point where it says, I want a new user. Well, over here in memory, it has a description of a generic class called a user. And it says, oh, you want a new user? Oh, here's what it has. It needs to have a name assigned. It needs to have a social security number assigned. It needs to have a date of birth. These are all properties. Oh, you're giving me those. Oh, good, okay. Now I'm going to make a new object. This object is user Erik G with the following properties. And now it gets the definition for what it's supposed to look like from the user class, which is stored in memory. And then it makes an actual user object, in this case, Erik G. So what does that in fact? Well, if you're going to look at this, actually if you look at this class, one of the things in it, these are, by the way, properties. The property or characteristic of this user class would be things like name, social security number, date of birth. But then there's behavior, things it can do. Well, one of the behaviors is make a user. That's a very special thing it can do. It can make one of itself. Inside the definition of the class, you even describe when you make a new user, here's what to do. Here's how to assign the different points in memory and what the values are that you want them to be. That special behavior is called a constructor. A constructor. Literally, I want to construct one of these users now because my program told me I need one. What do? Well, I set certain properties like the name, the social security number, and the date of birth. And I do so with data that's been given to me by the program. That's a constructor. It's a specialized, defined behavior inside a class of what to do when you need to make an example of that class, an instance of that class, an object that is of type that class. An object is just a thing. That's all it is, of a certain type. You could have a user type object. You could have a email sending type object. You could have a car type object. That's all it is. So that goes over we just got over constructors. Again, a defined behavior inside the definition of a class that tells what to do when you need to make one of these class types. Good. Now, why do you do this? What are the advantages? Well, there's a few different things about object-oriented programming that are, in fact, really strong advantages when you're making software. And you'll bump into these. And by the way, these can be relatively simplified descriptions of some of these concepts. You can go into these in great detail later on in your training. But let's look at a concept called encapsulation. To encapsulate means to put inside a little capsule, like everything is inside there. What does it mean in terms of code? Well, it means that if you have a block of code, software code, it's supposed to do something, like maybe do some sort of math operation or whatever, there are parts of a software program that will use that block of code, that pre-made bit of computer code. The users only know what this does. They don't get to see how. Right here on the outside, if you will, of this code is a box that these guys don't get to look through. It's a black box. Whoever's using that, whatever part of the program says, do the following. Let's use an example. Let's call it a multiply. You can give it numbers x and y, and we'll multiply them, and it'll give you whatever the product is. You don't get to know what's inside there as the user. Now, as a software developer, you do. You're going to write that. But the program that's using it only knows that if it gives two numbers, it'll get back the product of those two numbers. It doesn't know how. That, the how, is called implementation. Encapsulation is hiding away the implementation from the user. And you do it for a number of reasons. One of which is they don't need to know. The other one is that there are many, many different ways to do this. Some more efficient and some less efficient than others. You can use the one that you want to based on how quickly it performs without needing to know how it does what it does. And finally, one of the reasons for encapsulation is that inside this black box, it'll be working with data. Data that's only used internally. Not the data that's given to it or the data that comes out, but the data it uses while it's doing its job. You don't want any other part of the program to mess with that data and change it accidentally while it's doing its job that it was called upon to do. So encapsulation is a way of organizing your code so that nothing besides the code that's inside this box, if you will, can actually manipulate the data inside it. It's all inside a capsule. That's encapsulation. And again, you go into much greater detail about this in the future. So one other concept related to object-oriented programming, and really it's related to anything involving the technology world, is the concept of state. You'll bump into this a lot. State means the condition of something. You could have a rock and it's out in the sun, the sun's beating down on it, and at 9 in the morning, its state as regards temperature is that it's at 65 degrees Fahrenheit. And then at 3 in the afternoon, its state is that it's at 97 degrees Fahrenheit. State is only used for things that can actually change over time, obviously. Well, where does this come in terms of programming? Well, here's a very simple one. In your first course, you covered hypertext markup language. The language is used to make web pages. Now, hypertext means taking text, some words, and giving them a way to connect to other linked documents, text documents. Here's the thing about these linked documents. They are static. That means they do not change state. They don't change condition. The way you write a page that's shown in 1997 If you don't change this code at all, and you look at that page in 2015, that page is the same. Because all it describes is display the following text with the following modifications to appearance. Not display the following text with the following modification to appearance that are based on a changing time, but just, it's always this way. Always make it look this way. That is stateless. The basic challenge of the internet, by the way, of everything related to the World Wide Web, is that essentially it's stateless. When you call for a page on a website, that page was supposed to be just a simple text document with some changes to the appearance of the text or the images and not change over time. And yet, as needs of the public and of business have advanced, they want those web pages to have state, to display different information based on who the user is, and many, many other factors. So much of the technology you're going to be learning as a software developer is a way to make it so that these web pages have state characteristics, even though that essentially at the bottom, they don't. It's a lot of fun to make that work, by the way, and there's many different ways to do it. But that's state. Now, how does state relate to object-oriented programming? When you're looking at a class, again, we'll look at a class user. Remember, it's a definition of properties and behavior. If you were to have one, but when you actually make one, when you construct one, now the actual instance of a user, all the different properties inside it can change over time. The name could be edited, the date of birth, the social security number, the properties we made up in our example a minute ago. Now, this object of type user has state. And part of what you do as a software developer is actually throughout your program, make sure that you check or change the state of the different properties inside any specific object that you've made to parallel things that are happening in the real world. You have a user that needs their name edited. You're going to actually check to see that you have a name there and it's the one you want to change, and you're going to change the actual name for the new one, and then you're going to make sure that that got saved somewhere, it got stored, so that the next time someone checks on the properties of this user, it knows the new name rather than the old one. That's a very basic description. That's a basic covering of how state relates to classes in object-oriented programming. Okay, one more really awesome thing about object-oriented programming that you're going to get into is called inheritance. No, this doesn't mean that your grandfather left you a yacht. What it means is, if you're defining a class, in this case we're going to have a little fun and say our class is called car. Well, actually, let's go very, very high level and say we're defining a class called a vehicle. Remember that you're going to have properties and you're going to have behavior. Behavior is things it can do. Properties are its characteristics. What are the properties of any vehicle? Well, there would be body style. There would be color, if I can spell color. There would be year of manufacture, and more. There's lots, right? There could be manufacturer, who made it. These are all properties. That's what you want to know about a vehicle. What color is it? Who made it? When did they make it? What body style does it have? So you'd also want to know, like, what kind of engine does it have? Then there's behavior. A vehicle could accelerate. It could decelerate. It could steer. These are all things a vehicle can do. Good, fine. So now, you can easily make an instance of this, and you'd have vehicle number 1. And you'd have to set the manufacturer as Ford. And you'd have to set the body style as a coupe. And you could set the year as 1957. And then the color, fire engine red. And by the way, it's a complete coincidence that I just heard fire engine outside. And that's going down in posterity. And you could have an engine type, gas engine V8. That's a nice hot rod. Good. So, fine, it's a vehicle. But actually, that's pretty precise. There's lots of other things that can be a vehicle. Couldn't a tank be a vehicle? Couldn't a motorcycle be a vehicle? Absolutely. And couldn't you have a sports car, and you'd have a sedan, and you'd have a truck? These are all vehicles, aren't they? They all need to have these kind of properties: manufacturer, body style, color, year manufacturing, engine. They all have these behaviors. So, but then they have things that could be different, that are specialized to that type of vehicle. Here's where inheritance comes in. Inheritance is making a new class. Let's make a class here called truck. And it inherits from this vehicle class. The vehicle class is the parent class. The truck is the child class. So what does that mean? Well, it means that it gets all of these properties and behaviors, but you can add in some. For example, one of the properties would be bed length. How long is the length of the bed on the truck? It would be towing capacity. You care about towing capacity on a truck, but you probably wouldn't on a coupe. And behavior, let's say that, behavior on a truck. I actually can't think of anything on that. Oh, let's say it's a dump truck. Then it would be dump the load. Good. The whole point is that you have these senior properties and behaviors that are part of the parent class. And a child class gets to use all of those properties and behaviors, but can add on more of its own. It has inherited those. And what that means is you don't have to rewrite this code. You just write the new ones, because these ones are already found somewhere. They're already defined. Again, code reuse is maximized. Good, so that's inheritance. Now, there's a thing called is-a and has-a. What this relates to is two other concepts in object-oriented programming you'll come up against. The inheritance one that we just talked about, and a thing called aggregation or composition. So, inheritance we saw before, which is taking a class and deriving another class from it that gets all that first parent class's behaviors and properties and gets to add on behaviors and properties of its own. Aggregation or composition is making an object that comes from a class by using other objects from different classes. It's plus. It's has a. Here's an example. You have a class called car. And then you have a class called engine. If you make a class, make an instance of a class, you could make a class car, you could have a Corvette. And you could have all of its properties, what color it is, all that sort of thing. Now you make a class of engine, which is a V8 gas engine. You could have another one that you made an instance of, which would be an electric engine. Those are both engines. your Corvette has a V8 gasoline engine. In other words, this instance of a car class has or is connected to this instance of an engine class. You have now aggregated or composed a very useful thing for your computer program to use, because your computer program may want to make changes to some of the characteristics or behavior of the engine, or make changes to some characteristic or behavior of the Corvette, the car itself, and yet these are all tied together. So if you change the engine significantly, it could affect something in the car. Again, the thing to know about all this in terms of object-oriented programming is that you are representing in code, in computer language, what happens in the real world. This is how objects in the real world behave. They are defined as your class, right? You have classes, you have descriptions of potential behavior, you have kinds of things. And certain kinds of things behave in certain ways and have certain characteristics. And certain kinds of things can be associated with, combined with others to form another thing entirely, i.e. a Corvette with a V8 gas engine. You can switch it out and have a V6 engine, but you'd be a wussy. You don't go fast enough. So that's is a and has a. This Corvette is a car. It's a member of the class called car. This Corvette has an engine. It has an instance of the engine class that is this exact set of behaviors and characteristics. That's is a and has a. That's inheritance and aggregation or composition. One more concept on object-oriented programming you're going to bump into is polymorphism. Sounds all fancy. Poly means many. Morphism means things related to change. Morph, change. Good. Watch a lot of comic book movies. That ought to be familiar. So what does this mean? If you have many related objects, object 1, 2, 3, and 4, and they're related because they come from different classes or child classes, they're related in some way. How do you treat that collection of related classes? And what polymorphism relates to is how behaviors that are found in one class can be implemented and used in other inherited classes. And the rules for how all of that happens are actually relatively easy to understand, and you can get into them mainly in your C# classes, but they're a central part of object-oriented programming. Basically saying, how do you set up, in terms of writing a computer program, how parent and child classes that are all united by some commonality, how do you set up how to work with them and how the relationships between them work? That's the basics of polymorphism. One final note on that is that one of the main uses of polymorphism is taking a senior level class. Senior class has nothing to do with high school, thank goodness. A senior class, or the highest, it's also called the base class, which can then have child classes off of it because they're inherited. And defining behavior here in the base class that this child class can inherit, can do. And that other children, different child classes, can also use that same behavior. That's what polymorphism relates to as well. Good, let's cover these two things. A variable and a constant. You bumped into these a few times in your training so far. Just a further couple notes about them, because they relate to state. A constant gets set once. It's a value that you need. The value could be something like 2.14. It could be the value Steve. It could be the value red. The constant gets set. and it's never changed throughout the entire conduct of the program, the entire operation of the program. A variable, however, does get set, and therefore its state can change from one moment to the next. It could be things like, sales discount. So your program can change that based on the sales volume of the customer or what the day of the month is or such. Sales discount will change. It can be set as 5%, and then a few weeks later drops down to 0, and then a few weeks later goes up to 12.5. So that orders that get processed have a different sales discount applied against them. That's a variable. And again, you're going to learn all about these things. Make many variables. It's just a way to say, listen, I don't know what this is going to be yet, but it could change, and so I'm going to set it, and I'm going to give it a name, sales discount, age, color, name. And then I'm going to know, my program is going to know that it could change throughout time. And my program is going to be the one changing it a lot. There you go. Now, what's a function? This goes back to the most simple basics of a program. Now, remember at the beginning, programs were literally sets of instructions. And so on, times thousands. That at the very beginning were literally on big paper cards where there were holes in the cards relating to the instructions. And this card would get fed into the computer one instruction at a time. The computer would execute the instruction and do what it needed to do overall to have a program run. So that consecutive linear operation to a program is quite basic to a computer. Well, here's the challenge. What if there's some series of steps you need to do over and over and over and over and over again? You don't want to write out the same instructions over and over again. So what you can do is you can have them over here in a little self-contained box called a function. And here's your steps 1 through 8. And then over here where you have your main program, you're bopping along, you're doing all these instructions, and then here it says, do this function. So it goes and executes all those and then comes back and continues on, and then later on you do the same thing. You say, do this function. And it jumps over here, does this series of steps, and comes back. These ones can vary. The function is the exact same things every time. Prepackaged code modules, little bits of computer language that you're going to write, lots of them have been written for you, which is convenient, that you're going to write and you're going to call in your main program. That's what a function is. Now, basics of this is that very often the function needs some data to do its job. In that silly example I used a minute ago of a multiply behavior, by the way, that means functions. That means what are the things it can do. See, in this multiply behavior, it's going to need two different numbers. We're going to call them x and y because that's what every algebra teacher in the universe uses, right? You need to give them these two numbers and then multiply, and guess what? Your result, a, comes back. So the function needs to know, what are you going to give me? I'm going to give you x and y. And it also needs to know, what am I going to give back? That's called the return. So this function, right here, you could give it 5 and 3. And it would give 5 and 3 to this multiply function. And it would give back 15. There you go. But the next time you want to call it, you might want to give it 2 and 7. And it'll give back 14. Either way, you don't have to write all these instructions out. You just write one instruction. Do this function with these parameters. These are called parameters. The parameter is what do you give the function? And then the return value is what you get back. So those are functions, and you're going to make a lot of them, and you're going to learn a lot more about how they work.